We now learn how to calculate the area enclosed by a curve and the x-axis between two values of x. We'll start off with two scenarios that we need to know. The first scenario looks something like this. We're given a curve, as we can see here, which has an equation y equals to f of x. And we'll often be required to calculate the area enclosed by this curve and the x-axis between two values of x, say x equals to a and x equals to b. In other words, we need to calculate the area that I'm currently shading in right now. Now, there's one thing that's worth pointing out when we look at this curve. Between x equals to a and x equals to b, we notice that this curve is above the x-axis. What this means is that f of x is greater than or equal to 0. So I'll just write that down. In this case, scenario 1, we're dealing with f of x greater than or equal to 0. Now, when that happens, the area is actually surprisingly simple to calculate. Indeed, the area is equal to the definite integral from a to b of f of x. And I'll just go ahead and box that formula. This will be true so long as f of x is greater than or equal to 0. But we'll also know how to deal with a second scenario. In the second scenario, we deal with curves looking a little bit more like this. And again, we're going to be asked to calculate the area enclosed by this curve and the x-axis between two values of x, say x equals to a and x equals to b. Now, to clarify what we're being asked to calculate here, I'm just going to shade in the area we need to calculate. So that's this area here in blue and this area in red. Now, I've used two different colors here to highlight an important fact. The blue area can be thought of as a positive area, and that's because this curve is above the x-axis here. On the other hand, the red area can be thought of as a negative area. Now, both of these areas are separated or split at the point at which the curve crosses the x-axis. And the value of x at which this curve crosses the x-axis, I'm going to go ahead and call it c. Now, the difficulty here is the fact that if we were to calculate the definite integral from a to c of our function f of x, we'd get a positive area, just as we saw in scenario 1. On the other hand, if we did the same thing for this negative area between c and b, the definite integral of f of x would give us some negative value. And so when we'd add the two areas together, they'll start canceling each other out. And that's not what we want. So when this happens, we need to use another formula. And in this case, the formula is the following. The area is equal to the definite integral from a to b of the absolute value of f of x. And I'll just go ahead and box that result. You'll definitely want to know this formula and make a note of this now. The advantage here is that this formula will always work. Now, how does this absolute value of a function actually work? Here's the idea. Remember, this curve crosses the x-axis when x equals to c. So that leads to the following. I'm going to go ahead and rewrite this definite integral, but I'm going to split it into two integrals at x equals to c. That would look like this. The integral from a to c of the absolute value of f of x plus the integral from c to b of the absolute value of f of x. And now, for x values between a and c, we notice that the curve is above the x-axis, meaning f of x is positive here. When that happens, the absolute value of f of x does absolutely nothing at all, meaning we can get rid of the absolute value. On the other hand, for x values between c and b, we notice that the curve is below the x-axis, and that tells us that f of x is negative here. And when that occurs, the absolute value of f of x turns into negative f of x, which makes it positive. So that would look like this. This equals to the definite integral from a to c of f of x. Remember, f of x was positive between x equals to a and x equals to c, plus the definite integral from c to b of negative f of x. Remember, f of x was negative between c and b, and placing a negative in front of it will turn it into positive. This can now be rewritten as the definite integral from a to c of f of x minus the definite integral from c to b of f of x. And that is what the absolute value function actually does to our formula. Another way of thinking of this is to see that as soon as an area is negative, I'll just write negative area, we always subtract it. And so that's how to calculate the area enclosed by a curve and the x-axis between two values of x. Now that we've seen the formula, in our next video we're going to see how to actually use these formula with some examples. All right, everyone, I really hope that helps. Please help us by hitting like and even subscribe to this video. I wish you all the very best, and I hope to see you soon.